Okay, let's take a look at this example of finding an antiderivative that involves an exponential function. In this case, e to the 1 over x. So I'm going to find this antiderivative by substitution, and I want to let my substitution be for 1 over x, so that when we substitute, we'll have in our integrand just e to the u. All right, so remember, step 2 of the substitution, after you choose what part of the integrand you're going to substitute for, is to take the derivative of your substitution, right? So let's write this 1 over x as x to the minus 1 power, so that we can apply the power rule to find the derivative of u with respect to x, right? So we're going to compute du dx here, and according to the power rule, that derivative is going to be minus x to the minus 2 power, right? Bring down the minus 1 and subtract 1 from the exponent, which is the same as minus 1 over x squared. All right, let's try solving that for dx. So I'll multiply both sides by dx to start with here. So we'll get du is equal to minus dx over x squared. And then I'll multiply both sides by negative x squared, so that I'll have the dx isolated, right? So the minus signs will cancel each other on the right-hand side, and then, of course, the x squares will divide out on the right-hand side as well. So we end up here with just dx is equal to minus x squared times du. All right, so now we can substitute for dx, and let's see if that will allow us to eliminate the variable x from the integrand and replace that completely with just the variable u. All right, so remember, we're substituting u for 1 over x, so here we have e to the u power divided by x squared, and then we're substituting for dx, right? Minus x squared du, and of course here the x squareds will divide out, so we have the integral of minus eu du, and that is almost a form that we can integrate immediately. That's almost just a straightforward exponential function, except for the minus sign, which is a constant, so I can factor that in front of the integral. So I have minus the antiderivative of e to the u du. All right, so that's just your basic exponential function that we're integrating, and we know what the integral of that is. So easy, it's just the function itself. So the antiderivative here is going to be minus e to the u plus our arbitrary constant. And now let's undo our substitution. Of course, u is equal to 1 over x, so we get the antiderivative in terms of x is minus e to the 1 over x plus a constant. And there's our antiderivative.